Good evening to all jury's members. I think I'm the last one. And all respected scientists, professors, and my dear colleagues. Myself Abhishek Srivastava and Abhishek Kumar. I belong from Siddharth Nagar also, as my colleague has said. I also belong from Tarai Kshetra, Nepal border, which is coming from Uttar Pradesh. Under the motivation of our Honorable Prime Minister, as well as most of the eminent scientists, and being a student from science background, I always believe in how and why. So, which motivated me, which motivated me in the work of climate, because as you know, climate, whatever work we are doing, we must work keeping in mind how our climate is going on. So coming to the point, we have already chosen this hydrofluoroolefin, represent a new generation of compound designed to replace chlorofluorocarbons and hydrofluorocarbons, which are known contribute to global warming and ozone depreciation. As well as concerned, these hydrofluoroolefins have gained attention due to their significantly lower global warming potential as well as this ozone depletion potential. If we say as well as this objective is concerned, we have four objectives, like identify degradations pathway, first of all, like determine the primary pathways through which hydrofluoroolefins degrade in the atmosphere, including photolysis as well as reaction with atmospheric radicals we have taken. And analyze and characterize the intermediates and end products also. Apart from this, evaluate the environmental impact of hydrogen fluoroolefins degradation products, including their contribution to tropospheric ozone formation and secondary organic aerosol formation. At last, we have also, as well as objective is concerned, we have this investigate long-term fate, investigate the atmospheric lifetime of different hydrofluoroolefins and their persistence in the environment. That is very, very important, and we have collected some data. This abstract is based on simulation basis. We are having this environmental simulation. This work and develop and implement environmental fate models to simulate natural degradation process of hydrofluoroolefins, like soil simulation, water simulation, atmospheric simulation we have taken. Soil simulation we have utilized soil microcosm or lazimeters to mine degradation processes occurring in terrestrial environments. Water simulation we conduct batch or flow through experiments in aquatic, mesocosm or controlled laboratory settings. Atmospheric simulation use environmental chambers or reactors to simulate atmospheric conditions connected to hydrofluoroolefin degradations, including exposure to solar radiation as well as varying atmospheric composition. As far as methodology is concerned, in laboratory studies we have aimed to investigate the degradation kinetics and pathway of selected hydrofluoroolefins. And the experimental setup, we have taken experimental setup, analytical techniques, data collection and analytics, quality control. This we have already taken, and we have collected. Conduct as well as experimental setup is concerned, conduct accelerated degradation experiments using representative hydrofluoro compounds. Analytical techniques, we have utilized advanced analytical techniques such as gas chromatography, mass spectrometry, liquid chromatography, mass spectrometry, and Fourier transform infrared spectroscopy.
So 1 minute left.
And these things we have taken in methodology. And second, we have toxicological assessment. Toxicological assessment aims to evaluate the potential risk passed by these hydrofluoroolefins, like bioassays and ecotoxicological studies we have taken. We have taken data, exposure scenarios, risk characterizations we have already shouted out, we have taken. As well as on based of this data collection, we have this is our expected outcomes. Identification of degradation pathway provides comprehensive understanding of the primary degradation pathways and key intermediate products for different hydrofluoroolefins compounds. And environmental fate assessment, we see determine the environmental fate of hydrofluoroolefins degradation products, including their persistence and potential for bioaccumulation in various environmental matrices. This assessment is concerned quantify the risk associated with hydrofluoridegradation product in terms of ozone depletion and global warming potential. Conclusion, I want to say that understanding the atmospheric degradation of hydrofluoroolefin is crucial for sustainable development and climate mitigation strategy. These features definitely will be helpful for our future industries, and it aims to contribute significant to environmental science and policy makers also. Our objective is because I am proposed to work I am proposed to work with the proposed universities like Dr. Ramanath Awadh universities. So I have taken this one. Thank you so much.
You just tell me, this is your assumption.
Yeah.
This will be the metro.